So I've had some people ask me about how do I get started doing motion and what does it take? How quickly can I do it? I had some people express concerns about the complexity of setting up, for example, a Kinetix 5100 and doing motion there. And why would I use a Kinetix 5700 over some other Kinetix drive? In my opinion, one of the powers of the Rockwell platform and the Kinetix family is how integrated it all is. So I want to do a quick video to show that. So I have got a blank Studio 5000 program. This is basically brand new. So I'm going to go through the steps of what it takes to set up a servo system inside of Studio 5000. So first things first, we have to define the physical hardware that we're using. So I'm going to use a Kinetix 5300 today. So I'm going to just type in my part number here into this little filter. I'm left with one option for that catalog number. So I'm going to create it. So in my IO tree, I'm creating a representation of what I have in the physical world, right? So I'm representing my physical drive with this box now. I need to associate that physical drive with an axis in my programming environment. So I'm going to create a physical axis now. So I'll just call it my Kinetix 5300 axis. Click create and apply. I need to take this axis and put it into my motion group. And now I need to tell the axis which type of motor I'm using. So I'm going to come here, tell it that I'm going to choose the catalog number, and then I'm going to use an MPL-A220T. And I know this motor will work. I looked it up in the design guide. So once I have assigned the motor, there's a bunch of other options of what I can do of exactly how I want to control this motor as far as tuning and load observer and all that fun stuff. All I'm going to point out today for this quick demonstration is that the scaling page is how you would represent what your physical system looks like to the axis. So I'm going to stick with direct rotary coupled, which is basically saying my load is directly coupled to the motor. But say, for example, you had a linear actuator of some sort, you would choose linear actuator for your load type. You could define the type of linear actuator, whether it's a rack and pinion, a screw, etc. You define the physical characteristics of that linear actuator, and then your scaling is done. So I'm going to switch back to direct rotary coupled for now. Hit apply. Yes, okay. And I should be done as far as configuring my servo drive and my axis. So I'm going to go ahead and download to my PLC. This will take a second, but just in case you're wondering, I'm using a virtual PLC today. I'm using Studio 5 or Factory Talk. Oh, what's it called? Factory Talk Logix Echo is the newest virtual PLC from Rockwell. So now that I'm online, just to make this easier to see, I'm going to create a trend of my axis. So it'll take me a second to set this up. And I wanted to show what it takes to set this up from scratch without any real preparation. So I'm going to trend just my position, my velocity, and my acceleration of this axis. And let me configure my trend. There's a couple things I know I want to do. I need more time so we can see it. I like to do isolated graphing so I can see it more clearly. I always change the color of the pen from blue because it's hard for me to see that blue. So we'll go ahead and start that trend. So I think there's one thing I forgot to do. I forgot to go into test mode configuration. So that's a bummer. Let me go offline and let me turn on test mode. And let me download again. Now that I have test mode turned on, that allows the controller to function and act as if I had a physical axis, even though I don't have a physical drive with me. So I'm going to do motion direct commands now. If you're not familiar with it, motion direct commands are the way that we can command a servo motor to behave, to do something, without actually writing any code. It uses the same built-in instructions that we would use when we are writing code, but it doesn't require us to write any code to start. So just to kind of get a quick example of what we can do, I'll set up an incremental move of 5 of my positions and hit execute. And now you can see on my trend here, I'm trending the position, the velocity, the acceleration. And as far as Studio 5000 is concerned, as far as my PLC is concerned, I have officially moved this actuator, or moved my servo axis. So as you can see, pretty quick and easy. It's super convenient that all of the control for the drive and the servo motor are inside of Studio 5000. All of the configuration of how we're mapping our physical axis to our virtual axis, to our digital representation of that axis is done inside of Studio 5000. I don't need any other software. I just need to understand what it looks like in the real world and how to translate that into my software. Um, Hopefully this is interesting to you. Hopefully it's helpful. And thanks for spending some time with me.